Okay. So this chapter is a continuation of what we learned in 10th class. So what do we understand about light? We said that light can be understood both as a wave and as a particle, right?
Yeah.
Now, when you talk of reflection and refraction, can they be explained when it's a wave or when it's a particle or both?
I think it can be
Wave.
explained as a wave.
Okay. Can it not be explained as a particle? Reflection. Can't you understand reflection as a ball bouncing on a wall and so on?
Maybe.
Yes.
I mean, think about it for yourself. No, can it be explained by assuming that light is a particle? Okay. Anyway, so now when you look at a mirror and when there's a line there's a ball which comes and hits here and it's a smooth kind of a ball, how would you expect the ball to go back? Pranavi, how would you expect the ball to go back?
Is there gravity?
No gravity, let's say.
Then it would go in the opposite direction with the same angle as the incident.
Will it go in the opposite direction? If it
No,
falls
opposite,
here, it will go back. Here it will go back opposite. But if it falls
no,
here,
opposite, like on the other way, like
this way.
upward. Yeah, upward and opposite.
So it's getting deflected?
Yeah.
Hello, sir. I can hear.
Yeah, Pranavi, am I audible?
Yes, sir. Like my microphone wasn't working until now, so I was just. Can you hear me now?
Okay. But you were able to hear what I said? So we noticed that the ball gets deflected, right? Now, do we expect some symmetry here in the deflected? Sorry? Pranavi, what were you saying? Is she there?
No, sir. I was saying that if there's no gravity, then
there's no gravity. That's what Sujit asked. No, no
Can
gravity.
you hear me?
Yeah, no gravity.
Yeah. So if there's no gravity, so like it's an elastic collision, like retrace.
Right. No, I mean, if it is if it's projected normal to the surface, you would expect it to bounce back. Now, if it's not normal to the surface, would it bounce back? Take a ball and throw it on the wall at an angle. When you throw it like this, you catch it like this, no?
Makes sense, yeah. Yeah,
right?
yeah.
When you play with a ball?
Yeah.
Now, in this diagram, red is the way, red is of entry and green is of exit, correct? Do you expect some symmetry here?
Yeah.
What kind of symmetry do you expect?
Both the rays are symmetrical if they're.
So if this comes with a less tilt, with a less angle when it hits like this, what do you expect here? If it's closer to this line, the ray which bounces is also closer.
Yeah.
If it bounces with a greater angle, right. So then how do we represent it as an equation? How do we represent this as a mathematical equation, which we learned in our school?
Angle of incident is equal to
angle of reflection. So what does angle of incidence tell us? If the angle of incidence is more, it means that the object was thrown.
thrown closer to the
surface.
wall. Yeah, surface.
Exactly. So it's almost parallel to the surface.
Yeah.
Then there's almost no reflection, right?
Yeah.
Pranavi, does that make sense? If I is almost 90, then it's almost no reflection, right? It's just going on a straight line.
It's just going parallel.
There's no collision only. It's just touching and going.
Yeah.
And what if I is almost equal? If I is almost 0?
Then it would just bounce back. Looks like
it's perfect reflection, no?
Yeah.
So when I is ranging from 0 to 90, what is the variation you see? From perfect reflection to?
No reflection.
So do you see as value of I is changing? Do you see the quality changing there? Some quality changing there?
Yeah.
The amount of reflection, if you may call it so, is changing. Now, this scenario is pretty simple. That you throw a ball, you know how it bounces. But in reality, do we use only these plane mirrors or do we use other mirrors also?
We use other mirrors.
Which other mirrors do we use?
Concave and convex. And
correct. Where do you use concave, convex mirrors? Where do you see them every day?
ones, I guess.
In your car?
Yeah.
And is
That's
it
a convex
are those mirrors a little confusing?
Yeah, they miss. Yeah.
Okay. Now, concave, convex mirrors, they're a part of what kind of a surface?
A curved surface.
A sphere, right?
Yeah. Yeah.
Now, does angle I is equal to angle R? Does it apply to concave, convex surface also? It does, right?
Yeah.
It's true for any kind of reflection. But then, how for finding angle I and angle R, what do you need? Let's say there's one object O here. That object O is going and hitting the sphere. I want to find the angle of incidence. How do I find the angle of incidence? What do I need?
The perpendicular.
The perpendicular. What do you call that perpendicular?
It's called normal. Yeah, normal.
Now, if I take a circle, what is a normal? Normal is perpendicular to tangent, no?
Yeah.
If I take a circle and I take a tangent here, how do I get the normal?
It's
perpendicular to tangent and passes.
Perpendicular to tangent. So what is a special property? It? Pranav, yeah, correct. It what?
It's reciprocal, right?
It passes through the center.
It passes through the center. Yeah, slope will be reciprocal to that of slope of tangent. Negative reciprocal.
Yeah, negative reciprocal.
So this is a spherical surface. I want to know the normal. If I want to know the normal, what do I need to find?
First tangent. Tangent slope.
I don't need tangent. What did we say? The normal passes between the point and the
center.
So you know the point. So what else do you need?
The distance between
the center, no?
Yeah, the center. Yeah.
We call that center of curvature, right? Of a
yeah.
So is this my angle of incidence then? So what can I say? How will this ray go? It will go with an equal angle here, right?
Yeah.
Now let me call this the image I. So I know angle, if this is angle I, this is also equal to angle I, correct? Let me call this alpha, let me call this beta, and let me call this gamma. We see an interesting triangle here, right? In this triangle, what makes it interesting? The law of reflection. So this is I, and this is also equal to I. Why are they both equal to
I? Because angle of incidence is equal to angle of reflection.
Right. And why did we take C? Because the point connecting this A and C is the
that center, so
normal.
It's normal.
Why do we need the normal?
To find incidence.
Correct.
Angle of incidence.
Now, if I see this diagram, what property of 7th class do I remember? If I take gamma and I see all the angles inside, what property do I remember?
External angle property.
External angle property. So, what is the relation between beta, I and alpha? Beta is equal to
180.
I plus alpha, na?
Right, yeah.
And gamma is equal to?
Beta plus I.
Beta plus.
Oh, okay. Akansha joined. Good. So gamma is beta plus I, or if gamma is beta plus I, but what is I?
I plus 2 alpha.
I is beta minus alpha.
I is also I. So
2 beta minus alpha.
2 I plus alpha, yeah.
But I is beta minus alpha.
Yeah.
So 2 into beta minus alpha. Wait, let me write the equations again. I don't want I only want a relation between alpha, beta and gamma, and I'll tell you why. So I can say that gamma is alpha plus 2i, am I correct? And gamma is also beta plus I. I don't want I. What will I do?
Substitute.
Multiply this equation by 2 and subtract, no?
Yeah.
Yeah.
So 2 gamma minus gamma is gamma. So it becomes 2 beta minus alpha. So I'm getting 2 beta is equal to gamma plus alpha. Right? If you put the geometry aside, what we are seeing is because of what do I say? This angle of incidence being equal to angle of reflection, my alpha, beta, gamma are in. What are my alpha, beta, gamma in? Do I see a pattern in alpha, beta, gamma? Are they following a pattern?
Yes, sir.
What pattern is it?
Arithmetic progression.
Correct.
AP.
Yeah.
My alpha, beta, gamma are in arithmetic progression because my angle of incidence is equal to angle of reflection.
Yeah.
So that is the insight which I can take out of this, that my alpha, beta and gamma are in arithmetic progression. Now, if I take a triangle with just alpha, if alpha is very small, can I approximate it to be equal to sine alpha? If my alpha is very small, can I approximate it to be sine alpha? Limits you learnt, no?
Yeah.
When x is very small, x is almost equal to?
Yes. Sine.
Yeah. So my alpha, I can approximate it to be sine alpha. Because see, I'm not interested in alpha, beta, gamma. I'm interested in from the pole to object. What do you call the distance? Object distance, no? You call it U. From center to pole, what do you call the distance? R.
R.
And you call this V, no? You learned in your 10th class. This is a notation. U is object distance. V is image distance. It's kind of like your speed only, initial and final. U is initial, V is final. And your radius is R, radius of the sphere.
Sir, what is a pole?
Pole is the center of the spherical mirror, no?
Oh.
Symmetrical center. So now,
And,
go on.
There wouldn't be any, I mean, it wouldn't be 90 degrees, like.
It would be. This would be 90. Oh yeah, correct. But we approximate that this distance is negligible. That's a very good question. Yeah, we make an approximation because A is very close to P. So now we say that sine alpha is almost equal to AP by, what is the hypotenuse?
AO.
Okay. Sine beta
Sine beta is
AP by
AC.
AC.
Okay.
Sine gamma AP by AI, right?
Yeah.
What can I say about AC and PC?
About what?
About AC and PC, Vijay.
Oh.
What can we say?
Okay, hold on a sec. Now, if I take alpha to be almost equal to sine alpha, if I take alpha to be almost equal to sine alpha, do I get anything interesting here? I get AO, AC, and AI. With AO, AC, and AI, do I gain anything? Will I be more interested in PI, PC, and PO, or will I be interested in AI, AC, and AO?
PI, PC, and PO.
Why will I be interested in PI, PC, and PO?
Because you want to find OP, I think.
Correct. So will sine alpha be more interesting or will tan alpha be more interesting?
Tan.
Why will tan alpha be more interesting?
Because there's
what is tan alpha? AP by PO. What is tan beta? AP by PC. What is tan gamma?
AP by TI.
TI. When alpha is very small, tan alpha is almost alpha, right?
Yeah.
So now I got tan alpha is AP by PO, tan beta is AP by PC, tan gamma is AP by PI. And we notice that alpha, beta, gamma are in AP. So what can I say? 2 AP by PC is equal to AP by PO plus AP by PI. What will happen to AP?
Cancel.
What is 2 by PC? 2 by R is equal to 1 by U plus 1 by V. Now let's zoom out a bit. What was the first thing we said? Angle of incidence and angle of
reflection is equal.
And because angle of incidence is equal to angle of reflection, what did we see?
Alpha, beta, gamma
Are in arithmetic progression. Then what did we say? If alpha, beta, gamma are in arithmetic progression, I'm not interested in the angle. I'm interested in the distance, correct?
Yeah.
So from the angle to get the distance, what am I using? The approximation that
Alpha is equal to tan alpha.
Almost equal to tan alpha. So then when we get tan alpha, what are we getting? In the numerator, whether it is tan alpha or tan beta or tan gamma, in all of them in the numerator, what am I spotting? What am I spotting in the numerator of tan alpha, tan beta, tan gamma? Pranavi, are you there? Pranavi, are you there?
Yes, I'm there.
Yeah. So in all the three of them, what am I
Yes,
seeing?
sir.
First, I said alpha, beta, gamma are in geometric progression. What's the next step I'm doing from there? Sorry, arithmetic progression. What's the next thing I'm doing? I'm converting the angle into Pranavi, what am I doing?
Distances.
I'm converting the angle into. Yeah, Sujit, please go ahead.
Tan.
Tan. Why am I converting angle into tan? What do I wish to achieve by converting angle into tan?
We want to find OP.
What is my goal? U, V, and R.
Yeah.
So is tan a medium to reach the goal?
Yeah.
So that's why I'm converting the alpha into tan alpha, because from the tan alpha, I will get U, V, and R. But in the tan, I'm getting AP now. So what is it? What interesting pattern am I seeing? Because alpha, beta, gamma, see, look at it this way. I need 2 beta is equal to alpha plus gamma. But this 2 beta is some 2 into 1 dirty fellow divided by radius. And alpha is that same dirty fellow by the object. The same dirty fellow by the this thing. So now what is happening?
It's cancelled.
The vertical height, I mean, from the point where the light is hitting the mirror till the pole, they're getting cancelled. So I'm getting 2 by R is equal to
1 by E plus 1 by E.
now, but half of the radius, you say that it is focus. Why do you say half of the radius is focus? If there's a light which is coming from infinity, where do you expect it to fall? This is the center, no? Light is coming from infinity. This angle should be equal to this angle.
Yeah.
Now, can we conclude that this point is the midpoint? If these two angles are equal? Can we conclude that this is the midpoint? And if yes, how? This is 90 degrees. This will be 90 minus I. This will also be 90 minus I. In this equation, if it's coming from infinity, what will U be? U will be infinity, no? So 1 by U will be?
0.
0. So 1 by V will be? 2 by R. So V is equal to?
R by 2.
So our equation is telling us that if the object is coming from infinity, the light is supposed to pass through the focus. So all the parallel lines have one common thing, they meet through the focus. Is it easier to find the center of the sphere or is it easier to find the focus of the sphere?
But without the center, you can't find the focus, right?
You can find the focus more easily. Throw parallel rays, lasers and see where they meet.
Okay, yeah.
Then from the focus, you can find the center. Double the focus, you get the center, no?
Yeah.
Ideally, see a focus, you get it as half of the radius. But in reality, finding the focus is easier than finding the center, no?
Yeah, yeah.
How will you find the center? You draw a sphere, take a protractor and then find the center and all. Or take a compass and all.
No, sir.
So you will take lasers, throw lasers. All the lasers will go meet in one point. That point is your focus.
Yeah.
But you guys got how we got the mirror formula?
Yeah.
Mirror formula came from the observation that these angles alpha, beta and gamma are in
Arithmetic
progression. We will see a puncture problem at the end of the class. Like we will derive our own mirror formula, a new mirror formula at the end of the class. But now I would want to see the magnification also. But before that, I'd like to I mean, I haven't thought through this before, but now while doing it, I'm getting this question. If it is, you know, the light is coming from infinity, we know that this angle and this angle are equal. Can I use geometry? Can I use geometry to say that this is midpoint? Let's say this is alpha, this is I, this is I. Now this is 90 degrees, no? It's hitting here. If this is I, these two are parallel lines. So this should also be I. Does that make sense? These two are parallel lines, no?
Yeah.
If this is I, this is also I, right? Now, if these two angles are equal, what can I conclude? If these two angles are I, what can I conclude? What kind of a triangle is it?
Equilateral.
Isosceles.
Isosceles, right? And if it's isosceles, what can I conclude? This side and this side are? Let me call this some x. So I say Cx is equal to?
Ax.
Now I would like to find the relationship between Ax and Px. Now this angle is 90 minus I. This angle is 90 minus I again. Can I find something about Px? Assuming that this P and this Y are almost same approximation.
You can say Px is equals to Py.
How can you say Px equal to Py?
Sir, what is the question?
How can I find the relationship between Px and Ax?
Sir, I didn't understand why you're assuming P and Y to be same.
Because the A is almost close to P, no? So Py will be almost 0.
Oh, okay, yeah.
So think of it. I'll try to tell you in the next class over how you can prove that x is equal to r by 2 if this is parallel line. If this line is parallel, and this is 90 degrees, this is going here. I wish to prove that this is the midpoint of these two. So this angle is I, this angle is I, this angle is 90 minus I, and that angle is 90 minus I. We wish to prove that this is the midpoint.
Yeah, we did that, right? We took U as infinite.
This is I. This is 90, so this is also 90. Oh, correct. This is also 90 minus I. Do you guys see what I did? This is I, this is 90 minus I, this is I. So if this is I and this is 90 minus I, how much is this?
90.
And this is I. This is 90, this is I. So how much is this? 90 minus I again, right?
Yeah.
Angle sum property. So if these two are 90 minus I, what triangle is this?
Isosceles.
If it's isosceles, then Ax is equal to xy. But Py is almost 0, so I get Ax is equal to Px.
Yeah.
So you can use geometry to prove that Cx is equal to Px. So any line which is passing through, which is parallel to the axis, will pass through the focus. So is this interesting that we defined focus to be the point where all the lines passing, all the parallel lines would pass through. But we have geometrically proved that all the parallel lines have to pass through half the radius.
Sir, if AP is really small, I could just like deflect opposite, right?
No, even
Like
if
in the
AP is
opposite.
very small, I can still have significant variation, no?
Yeah.
No, does that answer your question?
What is significant variation?
As in the variation matters. See, if I give you one tiny speck of idli and if I give you two tiny specks of idli, does the difference matter to you? I give you 1 by 1 lakh of an idli and 2 by 1 lakh of an idli. Does that matter to you? I cut an idli into 1 lakh pieces and give you one piece, or I give you two pieces. Will that make a difference? No, right? But if I give you 8 idlis and I give you 10 idlis, does that difference make a difference? Does that make a difference, 8 and 10? Yeah. So significant means that thing mattering eventually. So no matter how small the AP is, the angle of reflection, angle of incidence will still matter.
Okay.
Because the way in which the light is going will change.
Yeah.
Now this might seem a little irritating. All these approximations might seem a little irritating, but in physics we use a lot of approximations. As I told you the other day, the unfortunate thing about physics is we assume a spherical cow and then solve the problem. Does that make sense?
The center could be also really close to P, so it won't deflect backwards.
No, the center is not that close to P. No, we didn't assume that the sphere is that small. That's a good question, though.
Then I is small. Then I is small, right? Because when center is like normal, then
not necessarily. Your eye can still vary, no? It's up to me of laser, how do I send it?
Yeah.
It's only about I project the light onto a point which is close to the pole. That's the only thing I'm taking care of. I can always project it close to the pole at a greater angle, no? I can move my laser like this, no, Sujit?
Yeah.
I can move my laser like this. So, from this we got that 1 by F is equal to 1 by U plus 1 by V. Why? This 1 by F is nothing but 2 by R, no? So from where did we get this? We got this from the observation that the angles alpha, beta and gamma are in
arithmetic.
Now I'll show you a very, very obvious and fairly simple result. Let's say there's an object here, okay? And so there's light, which is so this passes through the focus. Sorry, let me. What are the two rays we take for the image of an object? One ray we take is passing through the parallel, because then that will pass through the focus. And the other ray, convenient ray is pole. At the pole, why will these angles be equal? Because for the at the pole, what is a normal?
Perpendicular to the axis.
At the pole, the normal is principal axis only. Why? The normal is the point joining this point and the... At the pole, why is the normal equal to principal axis? Because your normal is joining the point and the center.
Okay.
The point and the center are joined on the principal axis, no? So I take this, these two rays cut here. I hope you're all drawing it.
Yeah.
Now, this angle and this angle are equal, no? Why are these two angles equal?
Because incidence and reflection.
Correct. If these two angles are equal, this is 90, this is 90. What can I tell about both the triangles?
Similar triangles.
Similar triangles. Bade miya, chote miya, no?
Yeah.
They both have different size, but the same
Angles.
same
Yeah.
shape.
Yeah.
So what can I tell about H1, H2, U and V? H1 by H2 ratio will be same as?
U by V. Yeah.
That is height of object by height of image is equal to U by V. So we call both of them as the magnification. So if my V is high, what will happen to height of my image? If my image distance is very high, what will happen to my height of my image? As I keep going far, my image is getting same angle. As I keep going far, my image is getting?
It increases.
Yeah. Why? Similar triangles, right?
Yeah.
If this fellow is U, if V is KU, H will be
KH.
KH. So if my KU is increasing a lot, then my
KH will also increases.
so be it magnification or be it that mirror formula, where does all of this come from? Where do these two formulae come from? In one, you're using similar triangles, and the other, you're using which property? To find that they're in arithmetic progression, which property did you use?
External angle.
So
Yeah.
be it external angle property or be it the similar triangles, they both come from what?
Angle of incidence is equals to angle of reflection.
From geometry, right? We're using geometric insights.
Okay.
Why is geometry playing an important role here?
Because it's geometrical optics.
Acha, very interesting.
Because we consider light as rays over here, so.
Exactly. And in rays, the most important insight we are using is that the only piece, it's like you're a Sherlock and you're investigating a puzzle. And while you're investigating a puzzle, what is your lifeline? In this entire chapter, one main lifeline is angle of incidence equal to angle of reflection, right?
Yeah.
Besides that, which other geometric properties did you exploit? That the normal is? Normal is?
Linear.
The point joining that point, the line joining that point with the center.
Normal touches the center.
You're exploiting. That's why center of curvature becomes very important. Why does the center of curvature become very important? Because it gives you the center of curvature becomes important because it gives you the
angle of incidence.
Normal. And the normal gives you the
Angle of incidence.
As well as the
reflection.
Good. Then we also exploited the property that corresponding angles property we exploited. How did we exploit corresponding angles property? To prove that We use no. This is I. This is I. This is 90 minus I. 90 minus I. Isosceles triangle. Isosceles triangle. What did we prove through that?
The midpoint.
Midpoint. When we proved that it is a midpoint, what did we prove?
AX is equal to PX.
Correct. That the focus is equal to
the
half of
the focus is equal to
Central.
half of the like
radius.
Radius, yeah.
Because the focus is the midpoint joining the pole and the focus is the midpoint joining the pole and the center.
Yeah.
Center of the sphere. Center of curvature, as we call it. So now we define this as magnification. Why do we define this as magnification? Magnification is K now, the scaling factor. How much is it stretching? How much are you pulling? You pull more, what is happening? The image is
magnified.
Yeah.
Sir, can you explain the last part? I didn't understand properly. The magnification part. Like,
let me do it
by...
again. Yeah, it's okay. Let me do it again. So Sujit, take this fellow. If I take this line here, these two triangles are similar, right? Because this angle and this angle are equal.
Yeah.
This is 90, this is 90. All angles are equal.
Yeah.
I'll draw them again like this. This is height of object. This is the object distance. This is also angle I. This is the image distance. This is height of image. Now, if this U is becoming KU, if V is KU, K into U, right? Sujit, similar triangles, if this is 3, 4, 5, I blow air into the triangle and the triangle becomes bigger. The 3 became 6. What will happen to 4?
8.
And what will happen to 5?
10.
So this U is becoming K into U, multiple of U. Like 3 is becoming 6 now.
Yeah.
U is becoming K into U. What will happen to HI?
K into H naught. I mean K into
HO.
Yeah, K into H naught.
That's what we notice. HI by V is equal to HO by U. No, the ratios are same. Similar triangles. So that K is the magnification. So we define the magnification as HI by HO, which is also equal to V by U. What is magnification? How much the triangle has grown. Magnification is how much the triangle has grown. I blow air into the triangle is growing.
Yeah. Yeah, understood.
So we discussed 3 things. We discussed the mirror formula. We discussed why the focus is the midpoint of both, and we discussed magnification. If you guys are clear, I would like to go into the last concept for today, and then we solve problems. Shall I repeat what I did, or can I go forward? We are not in a hurry. Guys, we'll finish the syllabus. We're not in a hurry. This chapter will finish by October ending. Modern physics will finish in November. Whole December we have for revision. No hurry. So if you didn't understand, I'll repeat it again. No hurry. We still have 1 more week, 2 more weeks in October. Even if I sleep, this chapter will finish in October. Right? So no hurry. If you don't understand any part, I'll repeat it. Please tell me. Don't worry about your syllabus completion. Modern physics में 3 or 4 chapters are left. Easily we'll complete it. यहाँ पे dispersion and optical instruments are left. Those are small. By next week we'll complete this chapter, and last week we can complete those 2 chapters. Modern physics will complete in November. So December we have time for revision. That's the only chapter left, no? Modern physics is the only chapter left, right?
Semiconductor का chapter is also there, ना?
वो पूरा modern physics में ही आता है ना, semiconductor.
हाँ तो
atomic physics.
Okay then.
वो तो जल्दी हो जाएगा, वो पूरा descriptive है ना. There's not much numericals there.
And there was this chapter of radioactivity knowledge.
हाँ, वो सब कुछ modern physics में ही आता है.
Okay. Yeah. Then only modern physics is left.
Yeah. So Pranavi, Akansha, did you guys follow the 3 derivations? Tomorrow I'll send a test for you based on the derivations. Again, puncture problems. Pranavi, did you understand the 3 derivations? Or do you want
Pranavi
to
said,
repeat one of them? Is she there?
no, I think she some gone somewhere.
Saurish, are you the co-host?
No, Tarun.
Krishna Priya ko bolo, she'll make you co-host.
Okay.
Because I think she has network issues. Pranavi, are you there? Could you unmute yourself?
Yes, I'm there, Josh.
Saurish is there.
Okay, fine.
But yeah. Shweta, are you there? You didn't speak anything today.
Shweta left.
I think
Shweta
she has
left.
electricity issues.
Yes, sir.
Also, Akansha is also
Pranavi,
not there.
you also live in Jubilee Hills, huh? You don't have power there?
No, sir, I'm actually a neighbor, but she has some problem in her house.
Oh, you're her neighbor, is it?
Like my grandparents' house is beside her house. So.
Acha, you're there in your grandparents' house now?
Yes, sir.
Acha. So then you call her to your house, not to attend the class. Yeah. So, okay. So can I proceed to the next one?
Yes, sir.
Okay. Now, when you look, when you see something through a thick glass, how does it appear? Does it appear to be of the same size or different size?
Different size.
Okay. If I put a thing inside a bucket full of water, and if I look at it, like if you put a mug inside a bucket full of water, does the mug appear a little different?
Yeah.
Yeah.
Why?
Refraction.
Why does refraction happen?
Because the density of the medium changes.
So when the density of the medium changes, what is changing?
The medium,
medium is changing. So what is changing? Optically, why am I seeing a difference?
The angle is changing.
The angle of the.
Like some.
What is changing with light? Why does light bend when mediums change?
The speed of light is changing.
Right? Speed of light is changing. That's why it depends on refractive index, because what does refractive index tell you? If I give you the refractive index, you will be able to tell me
the speed of the light in that particular medium.
Correct. So now let's look at this scenario where I have, let's say, air here, and I have some refractive index mu here, and I have an object here. Okay. And this object, there's a ray of light which is falling here like this, let's say. There's an object here, this yellowish object. There's a ray of light falling here. What is this? Angle of?
Normal to angle of incidence.
Because this is the normal, it's angle of incidence. Will the line come straight like this?
No. It bends.
No.
It will be R, right? Now if I join it backwards, so if I'm seeing from here, if I'm seeing this object from here, what will I feel? I'll feel that this object is at, will I think that the object is here? If I'm seeing from here, how will I see that the light is coming from? Will I feel that the light is coming from O, or will I feel that the light is coming from V?
Sorry, voice was breaking.
Yeah. Will I feel that the light is coming from O, or will I feel that the light is coming from V?
You'll feel that the light is come from V.
Why? Because I am used to light moving in a, what is the thing we study about light?
Straight line.
Straight line, correct. Right? What do we call it? What do we call that phenomena? Rectilinear propagation of right, no?
Yeah.
Lower classes we studied, no? Rectilinear propagation of light. So now, can I derive something which I know about O and V? Now, this is I, this is R. If this is R and this is a straight line, can I say that this is also equal to R? Wait, is this R? Yeah, it is.
No.
No, this is R, no? Yeah.
Yeah.
If this is R, then which else is R? This is R, no?
Yeah, the whole thing is that.
This whole thing is R. If this is R, can I say that this is R? Why, if this is R, why is this equal to R? These two angles are? Pranav, if this is R, why is this R? These two angles are?
I don't think the whole thing is R.
Yeah.
This is R, no? This is a normal, and this is the refracted ray. If this is R, is this equal to R? Why?
Corresponding.
Yeah, that will be equal to R.
Corresponding angles.
Oh, yeah, this one. Yeah.
So this guy is equal to R. If this guy is I, this guy is 90 minus I, this whole guy. And if this is I, can I say that this guy is I?
Yeah.
Why?
Alternate angles.
Yeah, alternate interior angles. What can I tell about sine I? If this is pole, this is A. What can I tell about sine I? Opposite by hypotenuse, no? AP by?
OP.
OP. What can I tell about sine R? AP by AV, no? So AP by PV.
Yeah, PV.
PV. But when the angle is very small, sine I is almost equal to tan I, no?
Yeah.
Why would I take tan I? Because if I take AP by OP and AP by PV, do I get anything interesting?
No.
I get hypotenuse. Hypotenuse I'm not interested, but the height of the object I'm more interested, no?
Yeah.
So I'll take tan instead. So if I take tan, sine I will be AP by OA. Sine R would be AP by OB.
AV.
Yeah.
But what do I know? 1 into sine I is equal to mu into sine R.
Yes.
1.
AV.
Sorry?
Yeah, isn't it AV?
Yeah, sorry, AV. So 1 into sine I is equal to mu into sine R.
Yeah.
Snell's law.
Yeah.
So AP by OA is equal to mu into AP by AV. So AV is the image distance. Image height of image is equal to mu into height of object. This depends on whether this is 1 or this is mu and so on. So initially the height was t, then the height becomes 1 by mu into t. By writing 1 into sin I is equal to mu into sin r, we get that the height which was t becomes mu t. Or rather 1 by mu t in the case of contraction. In the case of expansion, the t becomes mu t. So what is the shift in the height? T into 1 minus 1 by mu.
Sir, I didn't get this.
See, Akansha, let's write it this way. Mu1 sin I is equal to mu2 sin r. Sin I you're approximating to be tan I. Sin r you're approximating to be tan r. So tan में से वो जो height है वो cancel हो जाएगा. So you get mu1 by height of object is equal to mu2 by height of image.
Image, yeah.
So height of image is equal to mu2 by mu1 into height of object.
Yeah.
So if your second thing was actually air, if this was air and this was mu, then what is your height of image?
Hi is equals to mu ho.
But what if this was 1 and this was mu?
1 by mu h0.
Yeah. Now if this is 1 and this is mu, how do you expect the diagram to be? This is angle of incidence. If it's going to a thicker medium, angle of refraction will be more than angle of incidence, or will it be less?
Less.
Why? Because the mu is dominating, sin r will be reducing.
Yeah.
So it will come slightly
towards the normal.
Towards the normal. So then if it's coming towards the normal, what can I?
It should be near the normal, right?
Yeah, this will be near the normal. So if I extend it.
No, the normal is.
Oh, sorry. Yeah, near the normal. Correct. If I extend it, what will happen? This guy will go.
Yeah.
Above. So if this is 1 and this is mu, he'll go above. Am I correct?
Okay. Okay. Yeah. 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 And if it is mu is like the incident medium, then you get a smaller triangle.
Exactly.
Okay.
So from this, you get that if this height was t, this apparent height which you get, you'll get it as 1 by mu into t. But in this case, if this height was t, you get the apparent height as mu t. Mu is more than 1 now.
Yeah.
For example, if I give you a glass with refractive index 2 and I put an object with height 10 centimeters, right? Okay. What will that object's height appear like?
(10 by 2).
Yeah, it will appear like 5 centimeters.
5 centimeters. Okay.
So what is the shift?
What is the?
What is the shift in the height?
5 centimeters.
Yeah. But what will happen if I pass it through glass and it comes into air?
20 centimeters.
Yeah, this will appear like Vishwarupam, 20 centimeters. Bigger. Right?
Yeah.
Sir, our eye is below the surface, right?
Our eye is in the bottom surface. So it's backtracking.
Yeah.
Our eye is getting fooled.
Yeah.
This is the apparent depth concept. Next, one last concept for today is in Snell's law, you have mu1 sin I is equal to mu2 sin r, right? So now what will happen if your r is more than, so your sin r is equal to mu1 by mu2 sin I, right? What if your mu1 by mu2 is more than 1? Okay, let's take a numerical. Let's say mu1 is 2. So 2 sin I is equal to 1 sin R. So what am I getting? Sin R is equal to 2 sin I. What will happen if I pass light with an angle of 45 degrees, angle of incidence of 45 degrees?
Sin R is equals to root 2.
What happened there?
It won't be equal.
Why am I getting that? My maths is scolding me. Why?
Because
because mu is greater than mu2, so sin I will be less than sin R.
Fair enough. Even though it is less, your sin R cannot be root 2, no? What is going on? When is Snell's law valid? Snell's law is valid when what happens? Snell's law is valid only when? Which phenomenon?
mu2 and mu1 is less than 1.
No. Snell's law is valid when which phenomenon happens? Go back to the basics.
Refraction.
Correct. And I is equal to R is valid when?
Reflection.
Correct. So if you are getting this, then Snell's law is not valid. If Snell's law is not valid, uska matlab kya ho raha hai? Snell's law is not valid. Iska
then
matlab refraction is?
It's not completely.
It's not refraction at all.
Not happening.
So what happens?
It's not refraction.
What is the cutoff? What is the maximum possible value of I? What's the maximum possible value of I? Sin I max into 2, maximum I into 2 has to be equal to 2 into sine of maximum angle of index can be only
1.
So my sin I max can be
1 by 2.
So my I max has to be
30.
So if I pass light at an angle of 30 degrees, what is happening to my R? How much is R if R equal to 90, na? If 2 sin I is 1 equal to sin R. If 1 equal to sin R, how much is R?
90 degrees.
90 degrees. So if R is 90, what does it mean?
It's grazing around the...
It's grazing around the surface. What do we call that? So if you increase I a little more, what will happen? You learned in your class. Total internal reflection, no?
Total internal reflection. Yeah.
So we call this critical angle. Why do we call this critical angle?
Because above that, there's no more refraction. It starts reflecting.
Exactly. Because there's no more refraction, Snell's law is
valid.
So for critical angle is the highest possible value of
refraction.
Angle of incidence. Okay. Critical angle is the highest possible value of angle of incidence. And what is the angle of refraction when you have angle of incidence?
90
critical angle.
90.
So how do you find the critical angle when the refractive indices are given to you?
Put R is equal to 90 degrees.
Yeah. Apart from putting R equal to 90, what is another way of analyzing it? Put mu sin R equal to put mu1 by mu2 sin I equal to
1 by 2.
1. And then find I max.
Yeah.
By saying that sin cannot be more than
1 by 2.
Yeah. These are two ways of approaching the problem. One way is asking ki what value is allowed because I have to get a sign. One way is what value is allowed because I have to get a sign. Other way is to say that R is equal to 90 degrees. But is this concept clear? Sujit seems still a little confused. Sujit, let's do one more example. Now let us say, Sujit, this refractive index is 1.5. This refractive index is 1.8. So what is my problem? My sin R has to be 1, no? So 1.8 by 1.5 sin I. So what is my maximum value of sin I?
1.5
by 1.8. More than that, what will happen? This value will become more than
the critical one.
1.
Yeah, it will become.
Then sin R cannot be more than. Sin R cannot be more than. Sorry.
Why should wait? Sin R should be 1. So
maximum
it
1
can be 90 degrees.
Cannot be more than 1. At maximum, sin R is 1. At maximum, sin R is 1. Sin R need not be 1. R cannot be more than 90. So sin R is not more than 1. Now, but what if I do ulta? What if I do ulta? 1.5 sin I is equal to 1.8 sin R. What if I do this? Do I have any problem? Sin R is equal to 1.5 by 1.8 sin I. Which value of I is allowed? If I put I equal to 0, how much will I get? Sin R equal to? I is equal to 0, then sin R is equal to?
0.
0. If I put I is equal to 90, sin R is equal to?
1. 1.5 by 1.8.
So which value of I is allowed? From 0 to 90, everything is allowed. So if I'm going from a light, rarer medium to a denser medium, any angle of incidence is? If I'm going from air to glass, no problem. But the problem is only when I'm going from
glass to air.
Glass to air, because
there I have to be careful about my critical angle.
Yeah.
So my critical angle will be sin inverse of 1 by mu, as we saw here.
Yeah.
1 into sin I is equal to mu into sin R. But R is 90, so you get sin I is equal to, wait, from denser to rarer, no, mu to 1. So R equal to 90, so you get mu sin I is 1. So sin I is, so is this clear? Mu sin I is equal to 1 into sin R. From mu it is going to 1. From thick it is going to thin. Thick it is going to thin. So mu into sin I is equal to 1 into sin R. So mu sin I is 1. So I get sin I is 1 by mu.
Yeah.
Okay. Saurish, can you organize a reflection of what we did? We saw, I think, 4 concepts. 5 concepts in critical angle.
Yeah, including critical angle, it's 5.
Yeah.
Yeah, so from where did we start?
Can you guys answer this question?
We started from like angle of incidence is equal to angle of refraction. I mean, reflection.
Right. Angle of incidence is becoming equal to angle of reflection.
And then we did with the concave a concave mirror thing, where we saw where center is, which is not normal to where center is, and then we And then we we derived a formula for
a concave mirror, right?
yeah.
Okay, yeah. And then what did we do?
And then we did refraction. Yeah, we also proved that if I is coming from infinite, then the focus will be the midpoint.
Yeah, focus is also always the midpoint.
Yeah.
But if I'm having a ray coming from infinite, that ray becomes parallel to the axis, no? So if I have a parallel ray,
Yeah, it will
that
be
ray is
parallel
always
to
going.
axis. Yeah.
Correct. If I have a parallel ray, that always goes to the focus.
Yeah.
And then we prove that focus is always half of the radius.
Yeah.
Right. Then what did we do?
And then we found out the magnification formula.
Correct.
By using the similarity of a triangle.
Similarity of a triangle, right? Okay.
Yeah.
Okay.
So the relation V and R.
V and Pranavi?
UV and R.
V and R, are you saying?
Yeah, that's the formula of.
Yeah, V and R or V and U?
No, sir. UV and R. Basically, the formula for concave.
Yeah, that's a mirror formula, right?
Yeah.
Correct. Yeah, and after that we move to refraction, right?
Yeah.
So in refraction, what did we see?
Like how angle changes when it moves from one, like when light moves from one medium to another.
Correct. So if it's moving from a lighter medium to a denser medium, the image that I'm getting, is it becoming shorter or is it becoming longer? I'm going from lighter medium to denser medium.
Sir, I think I'm still a little confused in refraction. I understood, but I'm a little confused.
Okay. Tarun, are you there?
Yeah. Which one? This
Tarun,
one he wants this, is it?
Yeah,
refraction.
That refraction.
Particular aspect of refraction? Critical angle? Critical angle, or is it that height of object and all? See, what will happen?
That image part, whether the image is becoming longer or shorter.
So see here, see Sujit. This is 1, this is mu. Okay. Sujit, what is happening here? It's falling like this. This angle of incidence.
Yeah.
No? So if this is thick medium, it should go, this angle should be less, no? Like this.
Yeah.
So this will appear bigger.
Yeah.
If this is thin medium, this angle should be more, no? It will be lesser.
So when it is 45 degrees, it will be same.
Sorry?
If it is like 45 degrees, would it be like same?
Why?
Yeah, it will be depending.
Refractive index, no?
Oh yeah.
Correct.
That it's bending towards the normal because it's becoming thicker medium, no?
Yeah.
So that's why if the original height was t, the new height will be 1 by mu into t.
Sujit, angle of incidence and angle of reflection is equal.
Yeah, I know that.
Yeah, in case of refraction, it's not equal.
Yeah, I know.
Okay. Students, can you say what is one nice insight which we saw today? Something interesting, a very powerful insight we saw today, which was making problem solving simple. Some insight which we saw today. As I said yesterday, it's important for us to observe insights. Yeah, go ahead. Students, can you tell me one insight which you saw today? Shweta, are you there? Oh, she got disconnected. Akansha, tell me one insight which we saw today. Sujit, some idea which you really liked today, where you saw that, okay, that idea was making math simple, or the idea was making us see something in a simple way.
I don't know.
Which idea do you think? I mean, you wrote all of it in your book now. Which idea do you think was most interesting to you today?
I wrote at the beginning and then I lost space. Then.
But tell me which idea or which thing appeared very beautiful to you? Which simplification appeared very beautiful to you?
The quality of reflection decreases when it is closer to zero. When when it is closer to the surface, when it's almost parallel.
Yeah. What about you, Pranavi?
So I think it was the proof for why focal length. Why focus is half of the radius.
Okay. All of you come to the main room now.